Hello, welcome everyone, and my name is Dhiman Goswami, and welcome to my channel, The Common Math. And so, in today's video lecture, we are going to be understanding a very important theorem, that is the remainder theorem, which you most probably get in your ninth standard. And let's delve right into it. So, the theorem says that let p of x be any polynomial of degree greater than 1, greater than or equal to 1, and let a be any real number. If p of x is divided by linear polynomial x minus a, then the remainder is p of a. Okay, so now it's telling us that degree of p of x is greater than or equal to 1. Now, why is it so? It's only because that when you are dividing that polynomial by x minus 1, right? And what is the degree of x minus 1? So how do we find degree? Degree is the highest power in the polynomial. So x minus a is a polynomial. Okay, so power of x here is 1. So therefore this one's degree is 1. All right, so you can only and only divide a polynomial. So if you are dividing p of x by x minus a, then x p of x must be, p of x's degree must be 1. Are you getting it? So you cannot divide this, right? You cannot divide 4 by x minus 2. So this is not doable at all, right? Because 4 has a degree of 0, right? And x minus 2 has degree 1. So this is the thing when you are dividing polynomials, right? When you're dividing polynomials, like when you are dividing, when you want to find remainder and when you want to find, a number. When you're dividing number, let's say 7 is the divisor, then the dividend must be greater than or equal to 7, right? It must be 8. It cannot be 7 and you're dividing it inside 4, right? Then it just defeats the purpose because 4 itself becomes the remainder. You multiply 0 to it, isn't it? It doesn't make any sense in that case. So the long division only comes, so in case of numbers, the dividend must be greater than or equal to the divisor, right? So similarly, when you are dividing polynomials, right? So the divisor, in case of polynomials, the divisor, the divisor polynomial's degree must be less than or equal to the dividend polynomial degree. So this you need to understand. So that's what's happening. Since the degree of x minus a is equal to 1, therefore the degree of p of x must be greater than or equal to 1. It cannot be less than 1, right? So if less than 1, it goes only degree 0 will be there, and degree 0 means a constant value. So the polynomial must be a degree 1 polynomial. So that's the reason behind why p of x must have a degree greater than or equal to 1. Okay, so this comes out to be the value. Now we are going to understand how actually the next part of the remainder theorem is going to be justified. It says that p of x is divided by linear polynomial x minus a, then the remainder is just p of a. Okay, so now for that, what we just need to do here is we're going to check this. Watch. Now, why do we need the remainder theorem? We can, see, when x minus 2 is here, and let's say x minus 4 is given to us. Okay, so then directly that you put 1 here, x minus 2 will come. So here you put minus, here it will become plus. So it means like you're subtracting it from one another, right? So therefore, the remainder comes out to be 2 minus 2. So it is as simple as that. But when the dividend becomes complicated, let's say you have to x minus 2 and you have to take x power 4 plus 3x cubed minus 2x squared plus 5. If this is the polynomial, then it's it gets a little tricky to find the answer because you need to do the long division completely. Many steps will come here. And then finally, you are going to get a remainder here. So, and the remainder is going to be a polynomial of degree 0 that you'll understand now. Why? Because when the polynomial in the divisor itself has a degree 1, then its remainder will have a degree less than it. Okay, fine. So that's the main thing we are going to be using. Will come handy to find the remainder quickly. How? Let me just show you. So I'm just rubbing this thing off very quickly so that we have a little space over here. All right. So what does this say? Now we know that we can write P of X is equal to, since it is being divided by X minus A, so X minus A is going to be the polynomial. With that, you're multiplying another polynomial QX, right? This is the quotient polynomial plus the remainder polynomial, right? Now, as we have said that the divisor has got degree 1. Okay, so then the remainder has got always degree less than the divisor's degree. So the divisor's degree is 1. So there is only 1 degree less than that, and that is 0. 0 is the only less than 1 degree, right? That is 0. So therefore, the remainder polynomial has going to have a degree 0. Since remainder has a degree 0, so R of X is going to look like a constant. Fine. There is no play of X in here. It means it is like this, C into X power 0. Right? So X power 0 is 1, so it comes out to be a C. So R of X is just a constant. So therefore, P of X can be written as X minus A times Q of X plus R. I can just write it as R. Or, okay, fine. Let me still keep it as R of X only. And since R of X is a constant, so therefore it will remain the same always. Okay. So now what we need to do here is, if I take P of A, what will happen? In place of X, A are going to get replaced. So this will become A minus A times Q of A plus R of A. And R of A is nothing but R only, because there is no play of X here, isn't it? So R of A is nothing but the remainder only. So R of A is just R. Since R of X, let's consider it to be as R. So now A minus A is 0. So therefore this whole part becomes 0. So therefore P of A gives us the remainder. Are you getting it? So if you just put P of A, you'll find the remainder of it. Is it clear now? Now, let's take a quick example here. Okay. Let's take a quick example. So, yes, this much space is enough for us. Now, the example here, what we can take is, let's say P of X is equals to 2x squared minus 3x plus 5. And you are dividing it by, x minus 2. Okay. So if you're dividing it by x minus 2, then what's going to happen? If you want to find the remainder, you just need to plug in a here, right? X minus a, that means here x minus 2 it is. Okay. You can make it a little complicated as well. X plus 2 if you write, let's say if the divisor is x plus 2, then you can write it as x minus of minus 2. So minus 2 becomes our a, right? It's pretty simple in that manner. You can also take, you can also take, if it is 2x minus 3, you can take x equals to as 3 by 2. Are you getting it? You need to just find x minus a equals to 0 when it is. And that value of x, you plug it in here and you find the remainder. Okay. So in case of x minus 2, you just need to plug in 2 here. So p of 2 will give us the remainder, that is nothing but 2 times 2 whole square minus 3 times 2 plus 5. So this will give us 8 minus 6 plus 5, which is equals to 7. See, and 7 comes out to be the remainder. So that's it. So for any further problems and queries, you can simply solve the CBSE NCERT books there. And if you have even further doubts, you can just contact me on my Telegram page, The Common Cold, or you can just directly drop a comment below the video. Thank you so much for watching. Have a nice day.